All right, Monday, March 23rd, 2020. So the directions are going to say solve for the unknown side length, but I'm going to make a spoiler for you. It's not going to be a whole number. So I'm going to ask you guys to leave as a simplified radical because the SAT loves that kind of problem. But it combines multiple skills. It combines the Pythagorean theorem and your algebraic knowledge. So let's get right to number one. So let's take a look. I've got a 6 centimeter side, I've got a 3 centimeter side, and I don't know the third side, and it's a right triangle. So, leg, hypotenuse. Which do I know? I know a leg, and I don't know the hypotenuse. So I'm going to go to the Pythagorean theorem and say leg squared plus leg squared equals hypotenuse squared. So in my diagram, I know that one of the legs is 6. The other leg is 3. And I don't know the third side length, so let's call it x. I don't have to do that much algebra. Come on, red pen, work. There we go. So I don't have to do any subtraction on both sides to get the x isolated, so I'm really happy about that. 6 squared is 36. 3 squared is 9. And x squared is just still x squared. Okay? So now I've got x squared. 36 plus 9 is 45. So x squared equals 45. How do I isolate x now? Great. I'm going to square root both sides of the equation. So I've got 45 is equal to x squared, and I'm going to undo both sides by square rooting. So basically, x is equal to the square root of 45. But what do the directions say? The directions say leave as a simplified radical. When in doubt, break it up into a multiplication problem. Let's take a look at this problem. What can I break radical 45 into? Well, my standard multiplication problem is like 9 and 5. Well, I could break up 9 into radical 3 times radical 3 and then circle the twins, or I just know that the square root of 9 is in fact 3, and I can't break up 5, so it's still radical 5. So the unknown side of this problem, 3 squared plus 6 squared equals x squared. Well, that x squared has to be 3 times radical 5 equals x. Oh, sorry, centimeters. Stay with the units. So 3 radical 5 centimeters is equal to x. And what we can do is check our work. Because if I did 3 radical 5 quantity squared, a lot of people break it up like this. 3 radical 5 times 3 radical 5. 3 times 3 is 9. Radical 5 times radical 5 is 5. So that would be 45. I should have left more space. But yeah, so the important work is over here on the right. Okay. See if you guys can do 4 feet, 8 feet, x. What do I know? 2 legs and a hypotenuse. Okay, let me just put a little divider so I don't get confused. Okay, so I've got leg squared. Oh, a lot of ink. Leg squared plus leg squared equals hypotenuse squared, where the legs are 8 squared and 4 squared, respectively, and the hypotenuse is unknown, so let's call it x. 8 squared plus 4 squared, that'd be 64 plus 16 is equal to, x squared. So x squared is equal to, 4 plus 6 is 10, 6 plus 1 is 7, so that'd be 70 plus 10, that'd be 80. 64 plus 16 is 80. So how do I simplify x squared equals 80? Well, I'm going to square root both sides of the equation. So x squared gets square rooted and 80 gets square rooted. So in other words, x is equal to the square root of 80. But the directions say leave as a simplified radical. So x is equal to the square root of 80. Okay, and now, can I break up 80? Yeah, let's say I go with radical 10, radical 8, because I can break up 80 into 10 times 8, and that's equal to x. Nothing helpful so far, but I can continue to break this up. So let's say I've got radical 2, radical 5, radical 4, radical 2. Well, I see two things that I could do here. The point is, even if you broke this up all the way, I would break this up into radical 2, radical 5. That 4 can be radical 2, and don't forget I put this radical 2 over here. Are there any twins I can factor out? Yeah. So I'm gonna circle out the twins. I've got a 2 from here, and I've got a 2 from these two. So remember that I'm going to put it on the side so I don't interfere with the bottom part of. Actually, you know what? I have space. So in other words, I've got 2 times 2 times radical 5 is equal to x. So that'd be 4 radical 5 feet is equal to x. And you can check your work by doing 4 radical 5 quantity squared. 4 times 4 is 16. Radical 5 times radical 5 is 5. So 16 times 16 times 5 is 80, which is what we get from 8 squared plus 4 squared. You can check your work with a calculator. Okay. Now, I just put a little nice one right there. 1 yard, 3 yard, x yard. Well, once again, I've got 1 squared plus 3 squared is equal to x squared. I'm just going to write it down 3 times to get a little bit of a head. So I've got 1 squared plus 3 squared is equal to x squared. Well, 1 squared is just the exciting 1. 3 squared is the exciting 9. And so I've got 1 plus 9 is equal to x squared, or 1 plus 9 is equal to 10. 10 is equal to x squared. How do I undo the layers? I'm running out of space, so I'm going to do the square root right there. So x is equal to the square root of 10. And I can break this up into radical 2, radical 5. That's all I can do. So if I can't circle out a pair of twins and factor them out, I just leave it as radical 10. So radical 2, radical 5 is equal to x. There's no shame in breaking it up just to put it back together. So the solution is the unknown side length is radical 10 yards. Please put the units. Okay. All right, let's take a look at some problems on the other side now. What's different about problem number 4 that we don't have from 1, 2, and 3? Well, leg squared plus leg squared is equal to hypotenuse squared, but we only know, we know the hypotenuse and one of the legs. So now we got to solve for the other leg. So let's do it. So I'm going to call the first leg x, and I'm going to call the second leg 7. So x squared plus 7 squared is equal to 9 squared. Okay, pull that down. So now x squared plus 7 squared is equal to 9 squared. So we've got x squared plus 49 is equal to 81. So how do I get x isolated? For x squared plus 49 equals 81. I'm going to subtract 49 from both sides. I need to get a calculator because I'm holding a lot of things in place. So 81 minus 49 is 32. So x squared is equal to 32. How do I isolate x? I'm going to square root both sides. So I've got x squared equals 32, and now I'm going to simplify that radical for the square root of 32. Well, that pencil's broken. So I'm going to square root both sides, and I've got the square root of 32. What's a multiplication problem that I could do? Well, I could do 2 times 16 or 4 times 8. You know what? I kind of like 16 times 2. You know why I like 16 times 2? Because it's a perfect square, and I don't want to work if I don't have to. So that's just 4, and I can't do anything with that radical 2. So x is equal to 4 radical 2 feet. So x is equal to 4 radical 2 feet. Okay. See if you guys can do number 5 independently. If you're done with that, you can do number 6 independently. So try to do 5 and 6 independently. Okay, I'm going to jump right to it over here. Leg squared plus leg squared equals hypotenuse squared. So in this diagram, I'm going to stick with this multicolored pen. So I've got x squared plus 2 squared is equal to 5 squared. 2 squared is 4, 5 squared is 25, and how do I isolate that x squared? I'm going to minus 4 on both sides, getting me x squared equals 21. So I'm going to subtract, I just subtracted 4 from both sides. 25 minus 4 is 21. And that leaves me with x squared equals 21. So if I square root both sides, I'm left with just the variable x. And can I break up radical 21? Yeah, I mean, I suppose I could give it a shot. I could go 7 times 3. So let's make this radical 7, radical 3. Can I break this up even more? 7's prime, 3's prime. That doesn't really help me. So I could just put it back together and say radical 21. So we are in inches. So the unknown side length, the unknown leg, is the square root of 21 inches. So that's our unknown side length. Okay. 11 centimeters, 7 centimeters, and x. Well, now we've got Pythagorean theorem. X squared. Let me just put my x's ahead of time. So x squared plus 11 squared is, x squared, let's see, I got a little ahead of myself there. X squared plus 7 squared equals 11 squared. X squared plus 7 squared is equal to 11 squared. So x squared plus 49 is equal to 121. How do I get x isolated? I'm going to subtract 49 from both sides, getting me 72. So x squared is equal to 72. How do we get x isolated? So I'm going to square root both sides. And I can break up 72. I could do, I just thought of the first. So I could do 2 times 36. I could do 3 times, I think, 24. 4, I know 4 goes in there, but 6 times 12, 8 times 9. I would like 36 times 2. Why do I like square root of 36 times the square root of 2? Because 36 is a perfect square, and I don't want to work hard if I don't have to. So if I do this, I get 6, and radical 2 can't be broken down. So this is 6 radical 2 centimeters. So x is equal to 6 radical 2 centimeters. We're going to do one more problem, and I'm going to give you guys a sneak preview for tomorrow. Okay? Now, combine everything that we've learned. Oops. 8 feet, 5 feet, x, but I'm going to ask you guys to find all 6 trig ratios for angle theta. So, what I'm going to do, this problem in pencil. Actually, black pen, so I'm just going to assume you guys know you don't need the x color coded, so I'm just going to get right to it. So I've got x squared plus 5 squared is equal to 8 squared. 5 squared is 25. 8 squared is 64. And then I'm going to get x squared isolated by subtracting 25 from both sides of the equation. So that's gone. 64 minus 25, get a calculator, that is going to be 39. So x squared is equal to 39. And now I'm going to simplify this radical by square rooting both sides. So x is equal to the square root of 39. Can I break down the square root of 39? I'm going to try. I know it's divisible by 3, specifically 3 and 13. Well, 3 is prime and 13 is prime. And I don't see any twins, so I'm going to leave it as radical 39 feet. So I'm going to update my triangle because I like everything in one place. So I'm just going to, all I'm going to do is just put, I'm sorry about it, it's a little bit sloppy. I'm holding the iPad with my left hand. All right, let me just, did I make it worse or make it better? You get the idea. But the point is, if I were to draw a right triangle, and I've got a radical 39, and I've got 5, and I've got 8, and I'm trying to do the 6 trig ratios for angle theta. I always put this over here just to make my, sun came out. Soch katoa. I always put this little acronym right here just to remind myself what do they stand for. Soch katoa. So I'm going to look at angle theta, and I'm going to evaluate the sine ratio. The sine of angle theta is the ratio of an angle's opposite side to its hypotenuse. So what is the opposite side of angle theta? That would be the square root of 39. What is the hypotenuse of the triangle? 8. Let's do the cosine ratio now. The cosine ratio is the ratio of an angle's adjacent side to its hypotenuse. So the adjacent side of angle theta would be 5, and the hypotenuse would be 8. So the cosine of angle theta in this diagram would be 5/8. The tangent of angle theta is the ratio of an angle's opposite side to its adjacent side. Soch kah toa. So I'm going to go to the angle's opposite side, radical 39. And I'm going to go to the angle's adjacent side, 5. So the sine ratio, the cosine ratio, the tangent ratio, but the direction says find all 6 trig ratios for angle theta. What are the other 3? All you need to know are sine, cosine, and tangent, what they are, and you know what the secret is? Cosecant, secant, and cotangent are their respective reciprocal functions. So the cosecant of angle theta would be the reciprocal of the sine ratio, so that'd be 8 over the square root of 39. The secant would be the reciprocal of cosine, which would be 8/5. And finally, the cotangent would be the reciprocal of the tangent, which would be 5 over radical 39. There we go. That's a dense problem. We're going to end it here, and we're going to do more problems like this. In fact, there's going to be some problems where we're going to simplify the radical and then do the trig functions. Have a good day.